here. So this is section 4.5 on the exponential and logarithmic equations. So here we have exponential equations to start, and then we'll solve logarithmic equations. All right, so the guidelines for solving the exponential equation, so let me turn on the light here, are to isolate the exponential expression on one side of the equation, then take the logarithm of each side, and then use the laws of logarithms to bring down the exponent and then solve for the variable. So how would you know when you want to actually use this procedure to solve an equation? Well, when I talk about exponential equations, I mean equations that are going to have something of the form b to the x in it, or something where the x is in the exponent. So the best way to get an x out of the exponent is to take the logarithm of each side of the equation, because then you can use the power rule for logs that looks like this. All right, log base b of x to the p is p log base b of x. All right, so if I take the log on each side of this equation here, I have log of 3 to the x plus 1 equals log of 7, and then I can use the power rule for logs to bring the x plus 1 in front. So I have x plus 1 log 3 is equal to log 7. And then it's up to you whether you want to divide by the log 3 or just distribute it, but I would just divide by log 3 on each side and then subtract 1. So I have x plus 1 is equal to log 7 over log 3, and then x is log 7 over log 3 minus 1, which is fine for a case where you don't need to have a calculator, but this wanted the answer rounded off to 2 decimal places. So what I'll do is just go ahead and do this log 7 minus log 3, and then, divide it by, there we go, minus 1. So that's about to 2 decimal places, 0.77. All right, now, here's an interesting thing to note, that I use log base 10, or the common logarithm, but if I have 3 to the x plus 1 equals 7, and then I happen to do log base 3 on each side instead, then I know that the property of log says that log base 3 of 3 to the x plus 1 is just x plus 1, and then I can subtract 1 and I get the same answer, because I could use the change of base formula to rewrite log base 3 of 7 as log 7 over log 3 minus 1. So if you want to make it easier for yourself, I would go ahead and use the same base as the base of the exponential expression. All right, so that's just something to think about there. So let's try another one. And again, if you have any questions, let me know. But if I look at the next one, the exponential expression is not isolated because there's a 2 in front here. So I'm going to divide by 2 on each side to get the exponential expression isolated. So I have e to the 3x equals 6 divided by 2 is 3. Then I can use, in this case, the natural log, because that would be log base e. So natural log of e to 3x equals natural log of 3. Then natural log of e to 3x is just 3x. So then I have 3x is equal to natural log of 3, and then I can divide by 3 on each side to get x's natural log of 3 over 3. So then if I use a calculator to estimate this to 2 decimal places, I have natural log of 3 divided by 3, so that's about 0.37. All right, so that one is about actually the same difficulty. Just make sure that you use natural log to easily get rid of this e here. Otherwise, it would be a little bit more complicated than that. All right, so let's try another one. This one is a little bit different because the exponential expressions are on each side of the equation. So let's just start with taking the log on each side. So since also this is base 2 on one side and base 5 on the other, it really doesn't matter which base of log that we use here. You could pick the 2 or the 5 or just use the common logarithm base 10. So I'll just use log of 2 to the x minus 1 equals log of 5 to the 2x plus 3. So now I can use the properties of logs on each side to bring the exponents down in front. So I have x minus 1 log 2 is equal to 2x plus 3 log 5. Now, if you remember the first example that I did not distribute the log 3, right? But here, because I have x's on both sides and I need to isolate the x on one side of the equation, I am going to need to distribute the logarithm here. So let's distribute the logarithm here. So the log 2 in the log 5. So I have x log 2 minus log 2 equals, all right, now this will be 2x log 5 plus 3 log 5. Now, what I want you to notice is that I didn't write, when I multiplied x times log 2, I didn't write log 2x because I didn't want to accidentally think that it was log of 2x like this. All right, so I wrote it as x log 2 to avoid that mistake. Although another thing you could do is actually just write every time you have a log, put the argument in parentheses so that you don't forget also. But then my opinion on that is that these are some of the unwritten parentheses of mathematics sometimes that unless you have a reason to have those parentheses there, I would say that they do clutter things up. So don't actually, hold on. Sorry, a picture of an astronaut was about to fall off the wall. Hold on. Actually, I'll show it to you. So this is actually a picture. I don't know how well you can see it, but it's a picture that my dad got me, and it was hanging on the wall, and it was about to fall down. So I didn't want the glass or anything to break, so I thought I should go get it. All right. So hopefully this makes sense of why I would actually write this as x log 2 and not log 2x, so that I don't think that the x is being multiplied by the the 2. It's being multiplied by log 2. All right, so now I see that there is an x here and here, so I need to get the x's on the same side of the equation. So what I'm actually going to do here is I'm going to add this log 2 here to the other side since it doesn't have an x as one of its factors here. So I have all sort of different colors now, and this was actually a quite the trip to the store just to get these new markers, I'll tell you that. So there was a rowdy person at the dollar store among a lot of other things I had to deal with that day. So x log 2 is equal to 2x log 5 plus 3 log 5 plus log 2. Then I need to look at where the x's are at, and then what I'll do is I will subtract the 2x log 5 from each side. So I have x log 2 minus 2x log 5 is equal to 3 log 5 plus log 2. And then again, make sure that you know exactly where the x's are in the equation, but factor out the x so that you have log 2 minus 2 log 2 minus 2 log 5 x equals 3 log 5 plus log 2. And then all you need to do is divide by log 2 minus 2 log 5. So that will be 3 log 5 plus log 2 over log 2 minus 2 log 5. Now, that would be the final exact answer, but if I'm thinking about this, I might not even want to type all of that in the calculator because it's a quite the long expression to even type in the calculator. So one thing that you could do is simplify this. And again, this is optional, but if you want to get a decimal and it's a really long expression that you would want to type in the calculator, you could do this. I could bring up the 3 and the 2 to get log of 5 to the third plus log of 2 over log of 2 minus log of 5 to the second. So that's log of 5 to the third is 125 plus log of 2 over log of 2 minus 5 squared is 25. So log of 25. And then when I have the adding, I can use the product rule for log. So I have log of 125 times 2. And when I have the subtracting, I can use the quotient rule for log. So I have log of 2 over 25. And then I actually don't like that marker. I have no idea what some of these colors are, by the way. So then 125 times 2 is 250. And then I have the log of 2 over 25. And then I can use the change of base formula in reverse to get this as log base 2 over 25 of 250. So then instead of typing it into my calculator, say like this, so I have 3 log 5 plus log 2 over log 2 minus 2 log 5, right? I could just do the log base 2 over 25 of 250 and get the same result. So again, this wouldn't be something that you would necessarily want to do or need to do, but if you're calculating a whole bunch of these results in the calculator, I think that it would be easier to type it in like this than as the first result that we had here. So that's my only reason for showing this to you, is that some of these logarithmic rules aren't really necessary, but they do make things easier at some point. So this was as a decimal to about 2.19. All right, so now let's try this next one here so that you can see just another way of how this might be done here. So this one is actually very similar, but the base on the right side is a 6 instead of a 5. So I'll start with log of 2 to the x plus 2 equals log of 6 to the 2x minus 5. And then, by the way, remember how last time I did say that you could use any base of log that you wanted. So I think that just to prove that point, I'll actually do a different log this time and just do 2 on each, log base 2 on each side. That would mean that this side here is just x plus 2 then. All right, because the log base 2 of 2 is 1, so there you go. So that gives us that this side is x plus 2, but then here on this side, I can bring the exponent 2x minus 5 in front, so I have 2x minus 5 log base 2 of 6, and then I'll distribute the log base 2 of 6, so I have x plus 2 is 2x log base 2 of 6 minus 5 log base 2 of 6. And then I need to solve for the x, so I'll subtract the, I'll subtract the 2 on each side. Oh boy. Alright, so subtract the 2 on each side. So I have x is equal to 2x log base 2 of 6 minus 5 log base 2 of 6, and then minus 2. So the other thing that I want you to be aware of is I also think that it's important that even when you write something like this, that you don't accidentally do 6 minus 2 and say it's 4. Alright, so be very careful about that because it's a mistake that is easy to make. Then I would subtract the 2x log base 2 of 6 on each side. So I have x minus 2x log base 2 of 6 is negative 5 log base 2 of 6 minus 2. And then I will factor out the x here. So factor out this x. So that gives me 1 minus 2 log base 2 of 6 times x is negative 5 log base 2 of 6 minus 2. And then just divide by 1 minus 2 log base 2 of 6 on each side. So x is negative 5 log base 2 of 6 minus 2 over 1 minus log base 2 of 6. And then again, at this point, if you don't have a calculator that can do anything but the common logarithm, you would have to make this into negative 5 log 6 over log 2 minus 2 over 1 minus 2 log 6 over log 2. And then you see that for people who don't have a nice calculator, this became even more difficult to enter in the calculator. And on top of that, you also see it became more difficult even for the people who did have that type of calculator that could calculate logs with different bases other than 10. So let me go ahead and go for this calculation here. So I'll move this over here so that if you're still writing that down, you can see it. But So what is this? This will be, oh, this is quite the expression here. So negative 5 log base 2 of 6 minus 2 over 1 minus 2. And then this will be log base. Oh no, that's not the right button. All right. Well, I don't know how that happened. And now I don't even know. Okay, log base 2 of 6. And so that should give me the answer here, about 3.58. All right, so this is about 3.58. All right, so I hope that you enjoyed that. So again, if you have any questions, please just ask. So let's go to another one here. All right, so now we are back to one that only has the e in it, so as the base. So for problems like this, remember that natural log is the easiest log base to use. So natural log of e to the 3 minus 5x is equal to natural log of 16. So take the natural log on each side. Then natural log of e is 1, so we have 3 minus 5x is natural log of 16. Then subtract the 3 on each side, so negative 5x is natural log of 16 minus 3. And then divide by negative 5. So x is natural log of 16 minus 3 over negative 5. And again, let's go ahead and find this calculation here. So we have, let's see, there it is. So natural log of 16 minus 3, oh no, divide it by negative 5, so that's about 0.05. All right, so again, I don't have a preference like one way or another personally of leaving it as an exact form or as a decimal, because really, yeah, the exact form is nice, but the fact of the matter is these aren't equations that pop up every day, right? You'll more than likely do things by graphing them and then want to actually use the equation to back up what the graph says rather than just solving the equation every day. You will look at the graph and then see if you could solve equations to find certain points on the graph. So there you go. So now the next one is a little bit more difficult here. E to the 2x minus e to the x minus 6. But this is actually in quadratic form, because if you let, say, like a u be e to the x, then this is actually e to the x squared minus e to the x minus 6 is equal to 0. So you have u squared minus u minus 6 is equal to 0. So there I knew this was quadratic form. And then you can go ahead and factor this. So it is u minus 3, u plus 2 is equal to 0. And then set each factor equal to 0. So u could be 3 or u could be negative 2. And then since u was e to the x is 3, or e to the x is negative 2. And then what you do from here is you just go ahead and solve each of these equations. So take the natural log on each side. So natural log of e to the x equals natural log of 3. So x is natural log of 3. But here you have natural log of e to the x equals natural log of -2. But the domain of natural log of x is 0 to infinity. So that means that x, well, x it doesn't have a value over here because natural log of -2 is undefined, all right, or does not exist here. So that means that this is not possible. So the only solution is x is natural log of 3. And natural log of 3 is about 1.10. So I hope that you enjoyed that one. So let's try another one. Again, if you have questions, please feel free to ask. So we have x squared here times 10 to the x minus x 10 to the x equals 2 times 10 to the x. So what I'll do here is I'll subtract the 2 times 10 to the x so that the equation is set equal to 0. Then I will factor out a 10 to the x. So 10 to the x times x squared minus x minus 2 is equal to 0. And then I'll factor the x squared minus x minus 2. So that will give me 10 to the x times x minus 2 times x plus 1 equals 0. And so then I'll set each of these factors equal to 0. So 10 to the x equals 0, x minus 2 is 0, and x plus 1 equals 0. Now, when I look here, I take the log of 10 to the x equals log of 0. Well, that's not possible because the domain of the log of x is 0 to infinity. So the domain of log of x is 0 to infinity. So that's not possible. So x could be 2 or x could be -1. So those are the solutions here. All right, so that's it on the exponential equation. So before we move on to the logarithmic equations, I do hope that if you have any questions you would ask, but I I wanted to take a look at this question here, and if you want, you can just say your answer or type in the chat, but I'm wondering, like, if you look at this equation, like 6 to the x minus 1 equals 3 to the 2x, what is something that somebody might not understand about it? Or like if you just think about the problems that we've done so far, what would be maybe the one thing that you would tell somebody might be difficult about these types of problems? So if you want to, you can just say it or type in the chat, but I am wondering what all of you have to say about this. And I know some of you have a lot to say. Like Susan, you haven't said anything. oh, oh, yeah, that's a good answer, Susan. All right, so I I'm I would say that if I'm looking at this one, I think that uh I I think that there is a a real issue with this one because of the fact that there's a a 6 on the one side and the 3 on the other side. So like I didn't say this earlier when we were doing the problems where we had the right. This looks sort of very similar to this one, right? With the 2 to the x plus 2 and the 6 to the 2x minus 5, right? So I didn't say this earlier, but I I think that if you wrote 6 as 2 times 3, then the problem actually, I don't know why this is doing this. Then the problem actually looks a little bit different than it may have otherwise, right? So then what do you do in that case, right? Can you do something to the equation now that you wrote it like this? Well, all right. Well, could you actually go ahead and let me show you, because I was actually going to show you something, but um, okay, so it would be, uh-oh. Yeah, if I can get my graph to work, I will show you this, but yeah, so then one thing that you could do is you could distribute this exponent here, and I'll bring up the graph in a minute, but you have 2 to the x minus 1 times 3 to the x minus 1 equal 3 to the 2x. And then you could divide by the 3 to the x minus 1, and then you could subtract the exponents. So 3 to 2x minus x minus 1. So that would give me 3 to the x plus 1. And is that any better than what I started with? Maybe, maybe not, because then I could rewrite this as just 2 to the x times 2 to negative 1, and 2 to the x times 3 to the 1, and so this would be 2 to the x over 2, 3 to the x, equals 3 to the x times 3, then divide by 3 to the x, so 2 to the x over 2 times 3 to the x equals 3, then multiply by 2, so I have 2 to the x over 3 to the x equals 3 times 2, so then I can rewrite this as 2 over 3 to the x equals 6, and now, do you see that I have it with just one exponential expression and not two? And so then I can just take log of 2/3 x to the x equals log of 6, and then bring down the x, so x log 2/3 equals log of 6, and then divide by log of 2/3. So this answer becomes x is log base 2/3 of 6. All right, so now would that be better than, now this is where you have to ask yourself, would that be better than just solving it where we just did log of 6 to the x minus 1 equals log of 3 to the 2x, and then x minus 1 log 6 would be 2x log 3, and then distribute the log 6, so x log 6 minus log 6 is 2x log 3, then subtract the x log 6, so I have negative log 6 is going to be 2x log 3 minus x log 6, then factor out the x, so negative log 6 is 2 log 3 minus log 6x, and then x would be, well, you have to divide by that to get x, so x will be negative log 6 over 2 log 3 minus log 6. So which one is actually the, which one is the safest way to go? Or in which case are you more likely to make a mistake? Like, that's what I think that you have to think about. So what are some of the things that somebody might misunderstand about this type of problem? Well, it's just lots of things, right? Like, originally, if you remember, I said that you should isolate the single logarithm on each side, and there are ways to do that, but right, like, if you look at what I just did, I did actually get it down to a point where there was a single logarithm on each side, but it there's a lot of other places where somebody might misunderstand something. So that's one of the things, right? That's one misunderstanding, is that somebody could misunderstand that they must have one logarithm, or yeah, or one logarithm on each side, or they might misunderstand that they must have one exponential expression on each side, or they might misunderstand uh, which log rules to use. So those are three things that I think that people might misunderstand, and there you go. So again, like, if I do this, I can show you that those two results I got are exactly the same. So there you go. So now let's try the logarithmic equations. So again, there's always more than one way to solve all of these. So here we go. So for the logarithmic equations, just isolate the logarithmic term on one side of the equation, and then write the equation in exponential form, or raise the base to each side of the equation. So that just means exponentiate each side. So there is a name for that. It's called exponentiation. And then solve for the variable. So it says that we need to write the logarithmic term on one side, so isolate it, and we might need to combine the logarithmic term. So in this very first one, we have two uh, logarithmic expressions that we need to actually combine. So now we have the adding here, so I'm going to use the product rule for the logs to rewrite this as log base 3 of x minus 5 times x plus 3 is equal to 2. And this is all inside of the same argument of the log. So now I can exponentiate. So all I've done so far is I combine the logs, and then I'm going to write the exponential form. So if I do 3 and 3 on each side, that exponentiates this, so that this on the left becomes x minus 5 times x plus 3 is 3 to the second. Then if I distribute, I have x squared plus 3, x minus 5, x minus 15, and that will equal 9. So I'll combine like terms. So I have x squared minus 2x minus 15 is 9. Subtract the 9 to get x squared minus 2x minus 24 is 0. Then I'll factor, to get x minus 6, x plus 4 equals 0. So now I'll set each factor equal to 0. So x could be 6 and x could be negative 4. So there you go. So these came out fairly nicely here without any decimals or crazy answers like in the last set of problems that we did. So now let's look at the next one. Here I have logs. Now I could get all of the logs on one side of the equation, but before I do that, let's go ahead and let's just go ahead and do that. So log of 3x minus 3 minus log 4 minus log of x plus 1 equals 0. Then we'll combine the log terms using the properties of logarithms. So here we see the minus here, so we'll use the quotient rule. So log of 3x minus 3 over 4 minus log of x plus 1 equals 0. Here we see the minus, so we'll use the quotient rule again. So log of 3x minus 3 over 4 times x plus 1 equals 0. And then see how in the last problem we had log base 3, so we exponentiate it with the 3. Now this is log base 10, so I'm going to exponentiate with a 10. So 10 and 10. So again, remember that this here is just a log base 10 for the common logarithm. So I have 3x minus 3 over 4 times x plus 1 equals 10 to the 0, but 10 to 0, 1. And then I just multiply 4x, or 4 times x plus 1, or 4x plus 4 times 1. So I have 3x minus 3 is equal to, oh, by the way, we didn't check for extraneous roots, but I will check for that before we move on to the next page. All right, so equal 4x plus 4. So we distribute the 4 here. Then add the 3 to each side. So 3x is 4x plus 7. Then subtract the 4x. So negative x is equal to 7. So x is negative 7. So here is what you really do need to make sure of, though, is that you check for the extraneous roots, because if you look at the first one here, the 6 here, if I try to check for the 6, I have a log base 3 of 6 minus 5 plus log base 3 of 6 plus 3. That's log base 3 of 1 plus log base 3 of 9. So then that would be log base 3 of 1 is 0, and log base 3 of 9 is 2, because 3 to the second power is 9. All right, so 0 plus 2 is 2, and that one checks out. But so this one is the correct answer, but x equals negative 4 would not check out, because you can see there that if you tried to substitute the negative 4, you would have log base 3 of negative 4 minus 5, and that's log base 3 of negative 9, and you can't take the log of a negative number, because the domain is 0 to infinity. So that means that this is extraneous. But the same thing here, do you see that if you try to use x is equal to negative 7, then you would have log of 3 times negative 7 minus 3. That's log of negative 21 minus 3. So that's log of negative 24. So that would mean that this here is extraneous. So since the only solution you had here was extraneous, that means that this part B here has no solution. All right, so you should always check for extraneous solutions when working with logarithm problems or logarithmic equations here. All right, so hopefully that is okay, and we have just a few more here, and that would be, let's see, so if you have any questions, please ask, but I'm going to move this away so that the paper doesn't fall on the floor, but if you want me to move it back, just let me know. But this is our last set of examples here. So here, let's get all of the logs on each side, one side. So I'll subtract this pen is a junk pen, I'll tell you that right now. So log of 5x plus 1 plus log of 2 minus log of x plus 4. So now I'll combine the logs. So let's do that. All right, so now 2 at a time. So we have 0 is log of 5x plus 1 times 2 minus log of x plus 4. All right, so because this was adding here, I used the product rule for logs to get this. And then I see subtracting, so I'll use the quotient rule for logs. So I have 0 is log of 5x plus 1 times 2 all over x plus 4. And then I can exponentiate, but this is the common logarithm, base 10, so I'll use 10 on each side, so 10, 10. So 10 to 0 is 1. Then if I distribute the 2 here, I have 10x plus 2 all over x plus 4. I will multiply by x plus 4 on each side. So x plus 4 is 10x plus 2. Then subtract subtract the 2, so just get what you have. You have x plus 2 is equal to 10x. Then subtract the x, so 2 is equal to 9x. And then just go ahead and solve that here. So what do you have? You have x is 2/9. And you can go ahead and check that if you would like. So does log of 2/9 plus 4, does that equal log of 5 times 2/9 plus 1 plus log 2, and I see that those are equal to each other. So that means it's not extraneous, and this is the correct solution. All right, so D, we have natural log of 2 plus x equals 1. So the base is e for natural log, so I'll exponentiate e. So 2 plus x is e to the first, or just e. So x is e minus 2. So there is the solution here. And then I can check that fairly quickly. Right, I can check that, and I have natural log of 2 plus e minus 2, that's 2, 0 out, so natural log of e, which is 1, so that one checks out. I could have checked the last one mentally, but the 2/9 seemed like a lot more work than I would normally be willing to do. All right, so I think that checking these solutions on a calculator actually is a very good idea. It will save you some time. All right, next one. I see that the base is 3, so I'll exponentiate using the 3. So 2 minus x is 3 to the third, which is 27. So then subtract the 2, so negative x is equal to 25. And then go ahead and divide by -1, so x is -25. So log base 3, we can check this, log base 3 of 2 minus -25. That's log base 3 of 27, and 27 is 3 to the third. So that means that this is 3, and it checks out. So the one thing that I do want you to notice is that just because the x is negative doesn't mean that it's automatically the not a solution, because remember here the domain of this is 2 minus x greater than 0, so then I will actually subtract the 2 and then divide by -1, which means I need to switch the sign. So actually any numbers less than 2 could have been possible solutions, although only one of them works, and it's -25. All right, so keep that in mind as well, that just because a solution is negative doesn't automatically mean that it's extraneous. Okay, so that's all I have for today, so I'm going to stop this recording here.